November 12, 1944. The rain fell in sheets across the muddy banks of the Moselle River near Metz, France, as Lieutenant William Thompson stared at the swollen waters that separated the U.S. Third Army from their German opponents. What should have been a simple river crossing had become an impossible barrier that threatened to stall General Patton's entire eastern advance. Thompson believed they would need at least 3 days to establish a viable crossing under these conditions. He was about to discover how spectacularly wrong that assessment would prove to be. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how one overlooked engineer's revolutionary bridge-building technique not only changed the course of a critical campaign, but transformed how the U.S. military approached tactical water crossings for decades to come, revealing how innovation often emerges from those whose contributions history has been reluctant to acknowledge. Captain James Lincoln Washington had never intended to become a bridge builder. Growing up in Greenville, Mississippi, in the shadow of the mighty river that defined the region, he had developed a fascination with water's destructive and constructive power. The son of a carpenter who built modest homes across the Delta, Washington had shown exceptional mathematical aptitude from an early age. Despite graduating at the top of his high school class in 1932, the doors to traditional engineering schools remained firmly closed to a young black man from the Deep South. "If they won't let me through the front door," Washington often told his father, "I'll build my own staircase to the roof." That determination led him to Howard University's engineering program, where he graduated with distinction in 1936. When war erupted across Europe, Washington was working for a small construction company in Chicago, designing reinforcement systems for commercial buildings. His application to officer candidate school had been rejected twice before the Army's desperate need for engineers finally overcame institutional barriers in 1942. By November 1944, Captain Washington was serving with the 1159th Engineer Combat Group, attached to Patton's Third Army as they pushed toward the German border. Though assigned primarily to road maintenance and minor repair operations, tasks typically delegated to black units, Washington had earned reluctant respect from his white counterparts for his innovative solutions to seemingly intractable problems. Major William Hendricks, the commanding officer of the 1159th, had first encountered Washington during training exercises at Fort Belvoir in 1943. "The man has a mind like a steel trap wrapped in velvet," Hendricks noted in his personal journal. "He sees solutions where others see only obstacles, but he presents them in such a way that even the most stubborn colonel feels like it was his idea all along." That diplomatic skill would prove crucial as Washington's unit found itself unexpectedly thrust into the spotlight during the critical advance toward Germany. 5 miles away from Washington's position, Colonel Herbert Richardson paced the floor of a requisitioned farmhouse that served as the temporary headquarters for the 135th Engineer Combat Battalion. The situation maps spread across the rough wooden table told a story that was becoming increasingly familiar as the Allied forces pushed eastward. Another river, another crossing required, and precious little time to accomplish it. 3 days minimum, Lieutenant Colonel James Barrett insisted, pointing to the latest reconnaissance reports. "The river's risen 8 feet from the rains, currents running at 12 knots. We've lost 2 of our pontoon sections to artillery yesterday. Even if we had all our equipment, I'd still say 3 days." Richardson scowled. General Patton had made his expectations abundantly clear during that morning's command briefing. "I want that river crossed by tomorrow night. The Germans are retreating, and I don't intend to give them time to regroup behind the Siegfried Line. Find a way, or find another job." "What about that Bailey Bridge system the British have been using?" Richardson asked. Barrett shook his head. "We've got 2 sections, but they're allocated to the northern crossing. Besides, with these water conditions, we'd still need at least 48 hours to get a Bailey operational." The colonel's response was interrupted by a knock at the door. A young lieutenant entered, saluted, and handed Richardson a folded message. "Sir, General Patton wants an update on the crossing timeline within the hour." Richardson dismissed the messenger and turned back to his engineers. "Gentlemen, I need options now." Major Thomas Whitfield, the battalion's executive officer, cleared his throat. "Colonel, there might be another way. I received word that the 1159th has developed some new rapid bridging technique. They've been testing it during non-combat operations further south. The reports claim they can establish a crossing in under 12 hours, even in conditions like these. The 1159th, isn't that one of the Negro units? Asked Barrett, his tone making clear his skepticism. Yes, but their CO, Major Hendricks, is solid. I served with him in North Africa, Whitfield replied. Richardson considered this for a moment. At this point, I'd take help from the devil himself if he could get us across that river. Get the 1159th up here immediately, and Whitfield, find out everything you can about this miracle bridge system of theirs. Within 2 hours, Major Hendricks and Captain Washington arrived at the headquarters. The contrast between the two officers was immediately apparent. Hendricks, a tall, weathered man with prematurely grey hair, carried himself with the confident authority of someone accustomed to command. Washington, slighter in build, but with an intensity in his dark eyes that suggested a formidable intelligence, stood slightly behind his commanding officer, a leather portfolio tucked under his arm. After terse introductions, Richardson wasted no time. Major, I understand your unit has developed a new bridging technique. I need to know if it can work here, and I need to know now. Hendricks nodded. Colonel, with your permission, I'll let Captain Washington explain. He's the designer of the system. A momentary silence fell over the room as all eyes turned to Washington. If he noticed the surprise, or in some cases, the barely concealed disdain, on the faces of the white officers, he gave no indication. Thank you, sir, Washington said, stepping forward and opening his portfolio on the table. What we've developed isn't actually new technology, Colonel. It's a new application of existing materials combined with a different deployment methodology. He spread out several technical drawings. The standard pontoon bridge assembly requires sequential construction from one bank to the other, which is why it takes so long. Our system utilizes prefabricated sections that can be assembled simultaneously along both banks, then rotated into position using the current itself to assist deployment. For the next 15 minutes, Washington explained his design in precise, technical detail. He had named it the Parallel Assembly Rotation System, or PARS. Instead of building the bridge one section at a time from bank to bank, PARS allowed for multiple sections to be constructed simultaneously along the shoreline. Once assembled, these sections would be rotated out into the water like the hands of a clock, using the river's own current as a source of power rather than fighting against it. The beauty of it, Washington concluded, is that it requires no special equipment beyond what standard engineer battalions already possess. We've calculated that under current conditions, we could have a bridge capable of supporting light vehicles and infantry deployed in approximately 8 hours, with full tank capability within 12. Colonel Richardson studied the drawings carefully, his expression unreadable. Major Hendricks, you've seen this system in action? Yes, sir. We've deployed it successfully 3 times during training operations, once across the Meuse under similar conditions to what we're facing now. And you're willing to stake your reputation on this? What did you call it? PARS, sir, Washington answered. And yes, I would stake my career on it. Richardson looked up from the drawings to study Washington's face. Not your career, Captain. The lives of the men who will be crossing that bridge. Are you willing to stake those? Without hesitation, Washington met the colonel's gaze. I'll be the first one to drive across it, sir. A thin smile crossed Richardson's face. That won't be necessary, Captain, but I appreciate the conviction. He turned to his staff. Gentlemen, it appears we have our solution. Major Hendricks, how quickly can your unit be operational at the crossing site? We can begin staging immediately, sir. We'll need coordination with the pontoon company for materials. You'll have it. And anything else you require. Richardson folded Washington's drawings and handed them back. 8 hours, you said? I'll give you 10, but not a minute more. We need that bridge operational by 0600 tomorrow. Patton wants tanks crossing at dawn. As the meeting concluded and the officers filed out, Lieutenant Colonel Barrett lingered behind with Richardson. Colonel, are we really trusting this critical crossing to them? He asked quietly. Richardson's response was immediate and sharp. We're trusting it to engineers, Barrett. Right now, I don't give a damn if they're black, white, or purple with yellow polka dots. They have a solution when we don't. That's all that matters." Barrett nodded stiffly and left, leaving Richardson alone with his thoughts. The colonel was far from naive about the risks he was taking. Not just the tactical risk of an unproven bridging system, but the political risk of putting a segregated unit in such a critical role. If Washington's design failed, it wouldn't just be a setback for the immediate military objective. It would reinforce every prejudice that kept black soldiers relegated to service and support roles, rather than combat and technical positions. But as he studied the situation map once more, Richardson knew he had no choice. The crossing had to happen, and Washington's pass offered the only realistic chance of meeting Patton's deadline. By dusk, the banks of the Moselle had transformed into a hive of activity. Trucks from the 1159th and supporting units had arrived laden with pontoon sections, timber, steel cables, and all the materials needed for the bridge construction. Under Washington's direction, the river crossing had been divided into 12 sections, with teams working simultaneously on each segment. Captain Washington moved between the teams with calm authority, making adjustments to the assembly process where needed and solving problems as they arose. When a section of cable proved too frayed to trust, he personally demonstrated how to splice it for temporary strength. When two pontoon sections wouldn't align properly due to manufacturing variations, he calculated the necessary compensations on the spot. Sergeant Michael Davis, a former steelworker from Pittsburgh serving with the 1159th, watched Washington with undisguised admiration. "I've worked under a dozen engineers in civilian life," he told his squad, "and not one of them could match the captain for knowing exactly how things fit together. It's like he can see the finished bridge already, just waiting to be pulled out of the air." As night fell, powerful searchlights were set up, their beams carefully directed downward to minimize visibility from the German side of the river. Occasional artillery fire landed nearby, not directly targeted at the bridge construction, but rather general harassment of the area. Each explosion would cause a momentary pause in the work, men diving for cover. But Washington remained standing, seemingly unconcerned, checking his pocket watch and making notes in a small book. "Sir, you might want to take cover when those shells come in," a young corporal suggested after a particularly close impact. Washington glanced up from his calculations. "Thank you for your concern, Corporal, but I've observed the pattern. The German artillery has a 7-minute rotation cycle, and their targeting grid is approximately 200 yards north of our position. We're relatively safe here unless they adjust their fire." The corporal stared at him. "You figured all that out just by listening? Timing and mathematics, son. The war runs on both." Washington returned to his notes, then added with a slight smile, "But perhaps we shouldn't test my calculations too rigorously. A little caution never hurt anyone." By midnight, the parallel assembly was proceeding on schedule. 10 of the 12 sections were nearly complete, laid out along both banks of the river like giant puzzle pieces waiting to be connected. Major Hendricks had established a command post on the west bank, coordinating with artillery units to provide covering fire when the deployment phase began at dawn. Colonel Richardson arrived shortly after 0200 hours, accompanied by Lieutenant Colonel Barrett and 2 staff officers. The colonel observed the operation silently for nearly 30 minutes before approaching Washington, who was supervising the critical center section assembly. "Captain," Richardson said by way of greeting. Washington straightened and saluted. "Colonel, we're on schedule, sir. All sections are proceeding as planned. We should be ready to begin deployment at 500 as discussed." Richardson nodded. "I've just come from a meeting with General Patton. The timetable has changed. Intelligence reports indicate the Germans are moving up reinforcements faster than anticipated. We need this bridge operational at 500, not just beginning deployment." Washington's expression remained neutral, but his mind was racing through calculations. "That compresses our timetable significantly, sir. We'd need to begin the rotation maneuver in." He checked his watch. "Less than 2 hours. Can it be done, Captain?" Washington looked out across the dark water, then back at the sections under construction. "Yes, sir, it can be done, but we'll need additional manpower for the final assembly stages, and I'll have to modify the deployment sequence. You'll have 2 additional platoons from the 291st Engineer Battalion within the hour. Whatever else you need, just tell Major Hendricks. Thank you, sir. There is one more thing. Washington hesitated briefly. The original plan called for sequential testing of each section before allowing vehicles to cross. With the compressed timeline, we won't have that luxury. I'll need to implement an alternative validation protocol. Meaning? Meaning we'll have to trust the engineering, sir. The first vehicles across will effectively be testing the bridge at the same time they're using it for tactical purposes. Richardson considered this. What's your assessment of the risk? The design includes a safety factor of 2.5 for all load-bearing components. Theoretically, the bridge should support twice the weight of our heaviest tanks, but theory and practice aren't always aligned in combat conditions. I'm asking for your professional judgment, Captain, not theoretical calculations. Washington met Richardson's gaze directly. My professional judgment is that the bridge will hold, sir. I'd cross it myself without hesitation. That's good enough for me. Richardson checked his own watch. 0500, Captain, not a minute later. Yes, sir, we'll be ready. As Richardson walked away, Washington summoned his section leaders for an emergency briefing. The compressed timeline would require significant adjustments to their carefully planned sequence, but he had anticipated this possibility and prepared contingency plans. Sergeant Davis and the other section leaders gathered around as Washington quickly explained the new deployment schedule. We're moving up the timetable. Rotation begins at 0400 hours. That gives us less than 2 hours to complete all remaining assembly work. I need sections 3 through 7 ready for connection within 90 minutes. Captain, Section 5 is missing a critical coupling assembly, reported Corporal Jenkins. The replacement won't arrive until 3:30 at the earliest. Washington nodded. I'm aware. We'll modify the standard coupling using materials from the maintenance truck. Sergeant Davis, I need you to fabricate a substitute using the specifications I'll provide. Yes, sir, but with respect, sir, her field-fabricated coupling won't have the same load capacity as the standard issue. Correct? That's why we'll double reinforce the adjacent couplings to compensate for the reduced capacity at junction point 5 alpha. Washington quickly sketched the modified design on his notepad and tore out the page. Like this, the stress will redistribute according to Hooke's law principles. Davis studied the drawing, his expression shifting from doubt to understanding. Clever, sir, very clever. This might actually be stronger than the standard configuration. That's the idea, Sergeant. Now get moving. We've got a bridge to build and a war to win. As the section leaders dispersed, Washington turned his attention to the most challenging aspect of the accelerated deployment, the rotation maneuver itself. The power system relied on using the river's current as an assistive force rather than an obstacle, but timing was critical. If the sections were released in the wrong sequence or at the wrong moment, the entire structure could be swept away or worse, fold in on itself with catastrophic results. For the next hour, Washington refined his calculations, factoring in the river's increased flow rate, the weight distributions of each section, and the precise angles required for optimal rotation. By 3:30, he had a revised deployment sequence that would, if his calculations were correct, allow for complete bridge assembly by the 0500 deadline. The reinforcements from the 291st arrived at 0345, bleary-eyed and cold, but ready to work. Washington briefed their lieutenant quickly, assigning teams to the most critical remaining tasks. By 0350, all 12 bridge sections were complete and positioned for deployment. Major Hendricks approached Washington as the captain was making final checks on the cable tension systems that would control the rotation. "How's it looking, James?" Hendricks asked, using Washington's first name, something he did only when they were relatively alone or in moments of high stress. "It'll work, sir. The mathematics is sound." Hendricks smiled slightly. "I've never doubted your mathematics. It's the river I'm concerned about. She doesn't always read the same textbooks you do." Washington allowed himself a brief chuckle. "True enough, but we've built in enough redundancy to account for her moods. As long as the rotation sequence executes as planned, we'll have a stable crossing established within 55 minutes of initiation. And if it doesn't execute as planned," Washington checked his watch, "then we'll have to improvise, sir, but let's hope it doesn't come to that." At precisely 400 hours, Washington gave the order to begin the rotation maneuver. Green signal flares shot into the pre-dawn sky, indicating to all teams that the deployment phase had commenced. On both banks of the river, engineers released the braking mechanisms on the first set of bridge sections, allowing them to begin their carefully controlled rotation into the water. The concept behind PARS was elegantly simple in theory. Rather than building the bridge piece by piece from one bank toward the other, fighting against the current the entire time, Washington's system used the river's force as an asset. Each section was rotated from its position parallel to the shoreline out into the water, using a system of cables and counterweights to control the movement. As each section extended further into the current, the water's force actually assisted in pushing it toward its final position. The true genius of the system, however, lay in the simultaneous deployment from both banks. As sections from the west bank rotated clockwise into the river, corresponding sections from the east bank rotated counterclockwise. When properly timed, these sections would meet in the middle, their specially designed connection points locking together automatically under the pressure of the current. Washington stood at the western control point, using signal flags to coordinate the precise timing of each section's release. Through field glasses, he could see his counterpart on the eastern shore, Sergeant First Class Robert Miller, one of Washington's most trusted NCOs, mirroring his signals. The first 4 sections deployed perfectly, rotating out into the swollen river with meticulously controlled movements. Washington checked his watch again. Joe 417 hours. They were 3 minutes ahead of schedule. The 5th section from the western bank, the one with the field-modified coupling, began its rotation on signal. Washington watched intently as the massive structure swung out into the current. For a moment, it appeared to be rotating too quickly, threatening to overshoot its intended position. Washington immediately signaled for increased tension on the control cables. The response was immediate, but the adjustment created an unexpected oscillation in the pontoon section. "Compensating weight to the forward pontoons," Washington shouted to the control team. "Shift 2 men to positions Alpha and Charlie." 2 engineers immediately scrambled out onto the partially deployed section, carefully making their way to the designated positions. Their added weight at the critical points stabilized the oscillation, allowing the section to settle into its proper alignment. By 0430, 8 of the 12 sections were in position. The bridge was taking shape, stretching from both banks toward the middle of the churning river. But the most difficult part was yet to come, the connection of the center sections, where the current was strongest and the structural stresses most severe. Colonel Richardson had returned to observe the final deployment phase, standing silently behind Washington as the captain coordinated the complex operation. Even Barrett, who had been openly skeptical of the entire enterprise, watched with undisguised admiration as the innovative bridging system unfolded before his eyes. At 0442, the critical moment arrived. The final sections from each bank were rotating into position, approaching each other in the center of the river. Everything depended on these sections connecting properly on the first attempt. If they missed, the current would make repositioning extremely difficult, potentially causing cascade failures through the entire structure. Washington raised his binoculars, focusing intently on the approaching section edges. "Connection in approximately 30 seconds, he announced calmly. "Prepare for lock sequence." The tension was palpable as everyone watched the sections draw closer together. When they were less than 3 feet apart, Washington gave the final signal. On both banks, engineers released additional slack in the control cables, allowing the river's current to press the sections together with precisely calculated force. There was an audible clunk as the connection mechanisms engaged, followed by the metallic sounds of the automatic locking pins sliding into place. A cheer went up from the engineering teams as the center connection held firm against the powerful current. "Lock confirmed," shouted the monitoring engineer. "Center connection is secure." Washington allowed himself a brief smile but immediately returned to business. "Begin decking deployment on all sections. Priority to the center spans. I want full continuity in 15 minutes. The final phase of the bridge construction, laying the wooden decking that would allow vehicles to cross, proceeded with the same methodical efficiency that had characterized the entire operation. By 0458, a continuous roadway stretched across the Moselle, connecting the eastern and western banks. Washington performed a final inspection, walking the entire length of the bridge with Sergeant Davis, checking each connection point and support structure. The bridge swayed slightly with the current, but the movement was well within design parameters. At precisely EO 459, 1 minute ahead of schedule, Washington approached Colonel Richardson, who had observed the entire deployment process. "Bridge is operational, sir, ready for crossing operations." Richardson checked his watch and nodded with satisfaction. "Excellent work, Captain. Truly remarkable." He turned to his radio operator. "Inform command that crossing point Alpha is operational. The Third Army can proceed according to plan." Within minutes, the sound of approaching vehicles could be heard as the first convoy prepared to cross. As agreed in the planning phase, the initial crossing would consist of lighter vehicles, jeeps and trucks, to test the bridge under actual load conditions before committing heavier armor. The first jeep approached the western entrance to the bridge at 0505. Washington stood at attention alongside Richardson as the vehicle began its crossing. Both men watched intently as the bridge accepted the weight, the slight additional depression of the pontoons exactly matching Washington's calculated predictions. "How long will it hold, Captain?" Richardson asked quietly as the first convoy began making its way across. "Barring direct artillery hits, at least 72 hours, sir. After that, the waterlogged timbers will begin to compromise structural integrity. We should plan for replacement or significant reinforcement by the third day." Richardson nodded. "That's more than enough time. Patton will have the entire Third Army across by tomorrow night." As the morning progressed, the bridge proved its worth beyond even Washington's expectations. By 0700, light tanks had successfully crossed without incident, and by 0900, the first Sherman medium tanks were rumbling across the Moselle, their weight causing the calculated deflection in the pontoon sections, but well within the safety margins Washington had engineered. Major Hendricks found Washington around midday as the captain was supervising maintenance teams, making minor adjustments to the tension cables in response to the sustained heavy use. "The old man wants to see you," Hendricks said, referring to Colonel Richardson. Washington wiped his hands on a rag and straightened his uniform as best he could. "Everything all right, sir?" "More than all right. Just go see him. He's at the command tent on the east bank." Washington made his way across the bridge he had designed, weaving between the steady stream of military vehicles still flowing eastward. The command tent was buzzing with activity when he arrived, officers moving purposefully between map tables and communication stations. Colonel Richardson was in conversation with several staff officers when he noticed Washington. He immediately broke away and approached. "Captain Washington, good. Walk with me." The colonel led Washington outside the tent, away from the bustle of the command center. "Your bridge has exceeded all expectations, Captain. We've moved more men and material across the Moselle in 6 hours than I thought possible in 24. General Patton himself asked to be informed who was responsible." Washington maintained his professional composure. "Thank you, sir. It was a team effort." Richardson gave him a knowing look. "Indeed it was, but every team needs a mind behind it. I've recommended you for the Bronze Star, Captain. It's the least you deserve for this achievement." Washington was momentarily speechless. Decorations for black officers were rare, especially for engineering accomplishments rather than direct combat actions. "I'm honored, sir." "Truly? You should be. But more importantly, I've been authorized to inform you that your PARS system is being immediately adopted as a standard rapid deployment option for all Army engineering units. I'm detailing you to prepare comprehensive documentation and training materials as soon as this operation concludes. The implications were enormous. Washington's design would become part of the official Army engineering doctrine, his name permanently attached to a system that would save countless lives and contribute significantly to Allied tactical capabilities. "There will be resistance, of course," Richardson continued, his tone matter-of-fact. "Some officers won't appreciate taking instruction from, well, you understand the realities, but the results speak for themselves. 8 hours instead of 3 days. No one can argue with those numbers." "Yes, sir, I understand." Richardson studied Washington's face for a moment. "You know, my father was an engineer on the Panama Canal. He used to tell me that a well-designed structure doesn't care about the color of the hands that built it. It either stands or it falls based on the quality of the engineering alone. Your father sounds like a wise man, sir. He had his moments. Richardson extended his hand. Congratulations, Captain Washington. You've done the Army and your country a great service today. As they shook hands, the sound of distant artillery fire reminded them both that the war continued, regardless of individual achievements or moments of progress. Now get back to your bridge, Captain. Make sure it keeps standing until every last one of our boys is across. Yes, sir. As Washington turned to leave, Richardson added, And Washington, when this war is over, come look me up. The civilian engineering world could use minds like yours, and I know some people who won't give a damn about anything except your abilities. I'll remember that, sir. Thank you. Throughout the remainder of the day and into the night, Washington's bridge continued to perform flawlessly. By dawn, the following day, the majority of the Third Army's combat elements had crossed the Moselle, allowing Patton to maintain the momentum of his advance toward Germany. Sergeant Davis found Washington during the second night as the captain was checking tension readings on the eastern sections. Word spreading about what we did here, sir, Davis said. Heard some officers from another engineering battalion saying they're being ordered to learn that Negro bridge system as soon as possible. Washington continued his readings. It's not a Negro bridge system, Sergeant. It's just good engineering. With respect, sir, it's both, and that matters. Davis hesitated before continuing. Most of us never expected to do more than build latrines and dig ditches in this man's army. What you've shown here, it matters beyond just this river. Washington finally looked up from his instruments. What matters, Sergeant, is that our boys get across safely and effectively. Everything else is just noise. Davis nodded, understanding that Washington's apparent detachment was its own form of protection against the complexities of being a black officer in a segregated army. Yes, sir. Just thought you should know. The men are proud. Very proud. Washington's expression softened slightly, as they should be. Their execution was flawless. 3 days later, as predicted, the bridge began showing signs of structural fatigue. By this time, however, the Third Army had established more permanent crossings further north and south. Washington supervised the controlled dismantling of his bridge, ensuring that key components were salvaged for future use. As the last sections were being removed, a jeep pulled up carrying a brigadier general whom Washington didn't recognize. The general surveyed the dismantling operation briefly before approaching Washington. "Captain Washington?" the general asked. Washington saluted sharply. "Yes, sir." "Brigadier General Howard Stevens, Army Corps of Engineers." The general returned the salute. "I've been sent to personally review your parallel assembly rotation system. The reports from Colonel Richardson are, frankly, hard to believe without seeing the evidence firsthand." "The bridge has already been partially dismantled, sir, but I'd be happy to show you the remaining sections and explain the principles involved." For the next hour, Washington walked General Stevens through every aspect of the PAR's design, from the theoretical concepts to the practical deployment challenges they had overcome. The general asked pointed, technical questions that revealed a solid engineering background, occasionally nodding with appreciation at particularly elegant solutions. "You know, Captain, I've been in engineering for 30 years, and the most innovative solutions often come from those who are forced to approach problems from unconventional angles," Stevens remarked as they concluded the tour. Sometimes being outside the traditional thinking has its advantages. Washington recognized the general's statement for what it was, an acknowledgement of how Washington's experiences as a black engineer had contributed to his unique approach to problem solving. "I believe good engineering transcends all other considerations, sir," Washington replied diplomatically. "Indeed it does." Stevens handed Washington a sealed envelope. "These are your new orders, Captain. You're being reassigned to Fort Belvoir Engineering Research Division. We need your system documented, refined, and prepared for wide deployment. You'll be working with a team of our top bridge engineers." Washington accepted the envelope with mixed emotions. The assignment was a remarkable recognition of his abilities, but it also meant leaving the 1159th, the unit that had become something of a family over the past 2 years. "When do I report, sir?" "Not immediately. You'll remain with your unit through the Rhine crossings. We anticipate your expertise will be needed there as well. After that, report to Belvoir." Stevens extended his hand. "Congratulations, Captain. Your work here will save a lot of American lives before this war is over." The prediction proved accurate sooner than anyone expected. As the Allied forces pushed toward the Rhine, they encountered numerous water obstacles that required rapid bridging solutions. Washington's PARS system was deployed successfully 7 more times before the end of the European campaign, each implementation bringing refinements and improvements to the original design. By February 1945, as the Allies prepared for the final push into Germany, Washington's bridge system had become a standard part of the Army engineering toolkit. Training films featuring Washington himself demonstrated the deployment techniques to engineering units across the European theater. The most dramatic validation of Washington's design came during the infamous Rhine crossings in March 1945. When German forces destroyed the Ludendorff Bridge at Remagen, the only intact Rhine bridge captured by Allied forces, rapid deployment of multiple PARS bridges allowed American forces to maintain their momentum despite the setback. After the war, Captain Washington, by then promoted to Major, continued his work at Fort Belvoir, further refining the PARS system for potential deployment in the Pacific Theater. Though the Japanese surrender in August 1945 meant these bridges were never needed for their intended purpose, Washington's innovations found their way into the permanent Army engineering doctrine. Upon his discharge in 1946, Washington faced the familiar challenges of a nation still deeply divided by race. Despite his wartime achievements and the Bronze Star that General Patton himself had pinned on his chest, many engineering firms remained closed to him. It was Colonel Richardson, true to his word, who provided the opportunity that changed Washington's post-war trajectory. Now working for one of the largest civil engineering firms in the Midwest, Richardson recruited Washington to join a team developing infrastructure solutions for rapidly growing urban areas. The same principles that got tanks across the Moselle can get commuters across the Chicago River, Richardson told him. Engineering is engineering no matter where you apply it. Over the next 2 decades, Washington's bridge designs would become fixtures in cities across America, though few who crossed them daily knew the name of the engineer whose wartime innovation had influenced their design. In 1956, when the Army Corps of Engineers published its definitive manual on tactical bridge deployment, the parallel assembly rotation system was featured prominently, finally bearing the official designation Washington Rapid Deployment Method. By then, Major James Lincoln Washington had established his own engineering firm in Chicago, focusing on innovative infrastructure solutions for urban environments. When interviewed for a small engineering journal about his wartime contributions, Washington typically deflected personal attention. "I simply applied physics to a practical problem," he said. "The river taught me more than any textbook ever could. I just had the good fortune to be listening when others were too busy talking." The true impact of Washington's innovation extended far beyond the immediate tactical advantages it provided during the war. His success opened doors, slightly at first, then progressively wider, for other black engineers in both military and civilian sectors. His example became a quiet but powerful refutation of the prejudices that had initially relegated black units to support roles rather than technical and combat positions. In 1967, a young Army lieutenant named Robert Davis, the son of Sergeant Michael Davis, who had served under Washington in the 1159th, became the first black graduate of the Advanced Engineer Officer course to receive the Distinguished Graduate Award. In his acceptance speech, he cited Washington's Moselle River Bridge as the inspiration for his own pursuit of an engineering career. "My father told me that watching Captain Washington rotate that bridge into position was like watching a man conduct an orchestra," Lieutenant Davis said. "He showed a generation of us that excellence cannot be denied, even when recognition might be delayed." Washington himself, by then a successful civil engineer, with projects spanning the country, attended the ceremony. The photograph of Washington and young Lieutenant Davis, 2 generations of black engineers bridging not just rivers, but eras, appeared in several African-American newspapers across the country. When the Army Engineering School established its Hall of Fame in 1973, Major James Lincoln Washington was among the first inductees, his citation reading in part, for revolutionary tactical bridge deployment methodologies that changed the fundamental approach to water obstacle crossing, saving countless lives and contributing significantly to Allied victory in Europe. Washington, in his acceptance speech, remained characteristically focused on the engineering rather than the accolades. "A good bridge," he told the assembled officers and engineers, "does three things. It gets you where you need to go. It carries the load you need to bear, and when its job is done, it fades into the background, allowing those who cross it to focus on the journey ahead rather than the obstacle behind. If I've accomplished anything worth remembering, I hope it's been to build that kind of bridge, not just across rivers, but across the divides that too often separate human potential from human achievement." The legacy of Washington's innovative bridge system extended well beyond World War II, influencing military engineering doctrine through the Korean and Vietnam conflicts. The core principles of his design, simultaneous assembly, utilizing natural forces as advantages rather than obstacles, and rapid deployment through prefabrication, became standard elements of tactical bridge training for NATO forces. In 1984, nearly 40 years after his historic Moselle crossing, Washington was invited back to Fort Belvoir to observe a demonstration of the latest tactical bridging system, one that still incorporated fundamental elements of his original PARS design, though now enhanced with hydraulic systems and lightweight composite materials. As he watched the modern engineers deploy their bridge with practiced efficiency, Washington remarked to the accompanying colonel, "They're still using my rotation principle, I see." The colonel smiled. "Some innovations are too perfect to improve upon, sir. We've added technology, but the core concept remains unchanged. Your approach is still the fastest way to get across a river under combat conditions." Washington nodded, satisfied. Not bad for something drawn on the back of a supply requisition form in a muddy tent. During the Gulf War in 1991, American engineering units utilized advanced versions of tactical bridges that could trace their conceptual lineage directly back to Washington's innovation. When Iraqi forces destroyed bridges across key waterways during their retreat from Kuwait, U.S. Army engineers deployed modern variants of the Washington system to restore crossing capabilities within hours rather than days. Though James Lincoln Washington passed away in 1996 at the age of 82, his contribution to military engineering continued to influence tactical doctrine into the 21st century. During operations in Iraq and Afghanistan, American forces relied on rapid bridging techniques that, though vastly more sophisticated in materials and deployment mechanisms, still embodied the fundamental insights that Washington had developed on the banks of the Moselle. In 2018, when the U.S. Army Corps of Engineers celebrated its 150th anniversary, a special exhibition at the Pentagon included Washington's original hand-drawn PARS diagrams alongside the most advanced modern bridging systems. The accompanying plaque stated simply, "Different eras, different materials, same brilliant concept." Perhaps the most fitting tribute came not from official recognition or military histories, but from the granddaughter of Sergeant Michael Davis, who had worked alongside Washington during that crucial Moselle crossing. Now an engineer herself with the Army Corps, Captain Michelle Davis published an article in the Military Engineer Journal reflecting on Washington's impact. "My grandfather told me that Major Washington used to say, 'Engineering was like jazz,'" she wrote. "You master the fundamentals completely, then you improvise when the situation demands it." What he created on the Moselle wasn't just a bridge across a river, but a bridge across time, connecting generations of engineers who learned that innovation doesn't care about the color of your skin, only the quality of your ideas. Washington's legacy continues in the U.S. Army Engineer School curriculum, where cadets still study the principles of the parallel assembly rotation system as part of their tactical bridging instruction. Though modern systems have incorporated advanced materials and deployment technologies unimaginable in 1944, instructors still refer to the Washington principles when teaching the fundamentals of rapid water crossing techniques. The bridge that Washington built across the Moselle lasted only 3 days before being dismantled, but the bridges he built between worlds, between segregation and integration, between exclusion and opportunity, between what was and what could be have proven far more enduring. In 2022, when the Army Corps of Engineers broke ground on a new research facility at Fort Leonard Wood, Missouri, they named it the Major James L. Washington Tactical Engineering Center. At the dedication ceremony, the commanding general of the engineer school remarked, "Washington showed us that sometimes the best solution isn't to fight against the current, but to understand it so completely that you can make it work for you instead of against you." That lesson applies not just to rivers, but to all the challenges we face as engineers and as a nation. The story of Major James Lincoln Washington and his revolutionary bridge system remains a powerful reminder that innovation often emerges from unexpected sources, and that the most effective way to combat prejudice is not always through direct confrontation, but through such undeniable excellence that barriers become irrelevant. On the banks of the Moselle in November 1944, a black engineer from Mississippi showed what was possible when talent meets opportunity, creating not just a pathway for tanks and troops, but a model for how ability, when properly recognized and employed, transcends all artificial boundaries. Today, the site of Washington's historic bridge crossing bears no marker or monument. The river flows, as it always has, indifferent to the momentous events it witnessed. Yet in engineering classrooms and tactical manuals, in military history, and in the annals of black achievement in America, the impact of those critical hours when an insane bridge method helped U.S. troops cross in record time continues to resonate. The story of James Lincoln Washington reminds us that history is made not just by generals and politicians, but by individuals who see possibilities where others see only obstacles, who find innovative solutions to seemingly intractable problems, and who demonstrate through quiet excellence that the only barriers that truly matter are those we choose to maintain or choose to bridge. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.